Hi everyone, I'm Esther Cheng and I'm the webmaster for the ACM Los Rios chapter, and I'm also an ambassador for the Stanford Initiative Women in Data Science. And today I'll be going over an introduction to JIT/GitHub and data structures. So let's begin. So version control systems are tools to keep track of changes to files over time. They allow you to view or revert back to previous versions of files. They can track the history of code revisions from the current state of the code all the way back from when it was first tracked. And it allows users to reference older versions of their work and share code changes with other people. In JIT. So JIT is actually a distributed version control system as opposed to a centralized version control system. A distributed version control system means that every developer's computer stores the entire history of the entire project. Meanwhile, a centralized version control system basically means that there is only one main copy that everyone works on. So that's kind of the simplified version of the differences between the two. And then the entire history of an entire project is known as repository, and the repository is stored locally, which leads to our ability to use JIT locally on our own computers. The terminal is where you're going to be mainly using JIT, and there are several key terms that you're going to want to remember, and I've compiled the most important ones that I think you should know. So first off, we have CD, so that means change your working directory. And CD is going to allow you to alternate between directories. So let's say you have a directory inside your desktop directory. So you're going to want to CD into your desktop directory and then CD into the directory that you want. And then PWD means present working directory. So that's going to give you the pathway of the current directory that you're in. And then dot just means your current directory, so you're not going to go anywhere, you're just going to stay in your current directory. And then double dot means one parent directory above your current directory, so that's going to get you to the directory that your current directory is in. So referring back to my desktop example, so if you're in your current directory that's inside the desktop directory, when you cd double dot, you're going to go from your current directory into your desktop directory. And then if you do ls, that's just going to give you a list of all the files and folders in your directory. And then if you do mkdir, that's going to make a directory for you. And then rm will remove a file for you, cp will copy a file, and mv will move or rename a file for you. So when you're working in the terminal, there are a couple tricks that you want to remember that will make things so much easier for you. So first, when you have an incomplete name for something that already exists, try pressing the tab key for autocomplete or a list of possible names. And then if you want to retype an instruction that you've already used, you can just press the up arrow key on your keyboard until you see the actual instruction that you want to use. And then moving on to local repositories. So a repository stores files as well as the history of changes to those files. JIT repos tend to start off by not tracking any files, so that means that JIT isn't maintaining a history of those files. And then tracked files means that these files have been added to the JIT repository and can be in various stages of modification. So unmodified, modified, or staged. An unmodified file means that there is no new changes since the last version of the files that was added to the JIT repo. A modified file means that it is different from the last one JIT has saved. And then a staged file means that the user has designated as part of a future commit, usually through the use of the git add command. And then here is kind of an image/diagram that kind of makes things easier for you to understand. So we start off with untracked, and when you use the git add command, that directly allows you to stage the file. And then if you have an unmodified file, you can either remove the file or edit the file, which will get you to modified. And then modified, you can then stage the file. And then once you're at the staged status, then you can commit and everything will revert back to untracked until you make new changes. And then local repo commands. So here's a list of the most common commands that you will use with JIT. So JIT init is kind of like creating a box to permanently store panoramic pictures in. So it's going to be an empty box that you've created. And then JIT add is going to take a temporary photo of one thing that can be assembled into a panoramic photo later. And then you will JIT commit, which will assemble all the available temporary files into a panoramic photo while also destroying all of the temporary photos. Because they have been assembled into a panoramic photo, they are no longer needed. And then JIT status determines the exact status of each photo in your box. JIT log lists all the panoramic photos that we've taken so far. JIT show looks at what is in a particular panoramic photo, while JIT checkout rearranges files back to how they looked in a given panoramic photo that you want it to go back to. And it doesn't affect the photos in your box anyway. So that's kind of, the panoramic photo pictures are kind of a metaphor of your files that you'll be using. Hopefully it's easier to understand by explaining that way. Remote repositories. One feature of JIT is the ability to store copies of your repository on computers other than your own. So that means besides the local repository that you currently have, you can also store repositories on websites such as Github. That allows people to be able to see your repository and actually be able to store repositories on their computer as well. So there are a couple of important remote repository commands that I've listed below, and we'll go one by one. So JIT clone with the remote repository URL makes a copy of the specified repository on your local computer while also creating a working directory that has files arranged exactly the way it was sorted in the most recent snapshot of the downloaded repository. It also records the URL of the remote repository for subsequent network data transfers and gives it the special remote repo name origin. JIT remote add and then the repository name, repository URL, records the new location for network data transfers, while JIT remote -v lists all locations. JIT pull and then the repo name and then master gets the most recent copy of the files as seen in the remote repository, while JIT push, remote repository name and then master, pushes the most recent copy of your files to the remote repository. And then now we are moving on to the data structure section of this presentation. So linked lists. Linked lists are a linear data structure in which the elements are linked using pointers. There are 3 different types of pointers. The head pointer points to the first node of the linked list. The next pointer points to the next node. So if the next current node is null, that means we have reached the end of the linked list, while the prev pointer points to the previous node. There are different types of linked lists, and I'll go over them. So there is a simple linked list, also known as a singly linked list. Items can only be traversed in one direction, so that means there's only a next pointer, there is no prev pointer. And then a doubly linked list, that means items can be navigated forward and backwards, so that means there is both a next pointer and a prev pointer. And then circular linked list, that means the last item contains the link of the first element as its next pointer, while the first element has a link to the last element as its prev pointer. And then common operations in linked lists. So there's insertion, which adds an element at the beginning of the list. Deletion, that deletes an element at the beginning of the list. Display, it displays the complete list of the linked list. Search, it searches an element using the given key. deletes an element using the given key, and then it sorts the nodes of the linked list. The next data structure that we'll be going over is trees. Now there are a lot of different types of trees, but I won't be going too much into them. I'll just be giving a general idea of what a tree is. So a tree is a specialized method to organize and store data in the computer in a more effective way. It consists of a central node, structural nodes, and subnodes which are connected via edges. A tree is different from a linked list because it is nonlinear and is also a hierarchical data structure consisting of a collection of nodes such that each node of the tree stores a value. In order to perform any operation on a tree, you need to reach the specific node by doing a tree traversal algorithm. I won't be going too much into that either, but just know that there are 4 main tree traversing algorithms. There is level order, post order, in order, and pre-order. And that is about it for my presentation. I hope I was able to provide you a little bit more insight into JIT/GitHub and some of the data structure topics that I went over. Thank you so much for listening.